All right, so looking at number 6, we're going to use this table chart. Now notice I have my numbers here. These will be slightly different than your numbers because the program randomly generates. Use the same question but different numbers. And so we have the accompanying table shows the numbers of male and female students in a particular country who received bachelor's degrees in business in a recent year. And there are two parts here. So find the probability that a randomly selected student is male given that the student received a business degree. So the probability that the student is male given that they received a business degree. I'll use that notation. So given that they received a business degree, we are looking down this column. We give that they have a business degree, so we look down this column. Now the number of males down that column is 190,832 out of a total of 360,984. And so running over to my calculator and rounding to 3 decimal places, which is what we want to do, I take 190,832 and I divide it by 360,984, and I get, rounding to 3 decimal places, a probability of 0.529. All right, for part B, we want to find the probability that the student has a business degree given that they are female. And so for this case, we're going to look across this row. And so there are 170,152 business degrees out of the 1,049,110 females. So plugging that into the calculator, 170,152 divided by 1,049,110 gives me 0.162 as my probability. And so this is an idea of conditional probabilities coming from tabular data. And the thing to note is your first condition, your given condition, is either going to be a column or a row in your data. And so for this first one, right, given the business degree, I'm picking from this column. It's important to have the totals for each column and for each row.